Let's stop my share. Okay. Hello. Any questions?
Hello, Zach. I have a question about XDDB.
Right.
If the situation and use case is for example, three developer or one developer want to build a web application to build a minimum viable product. Do you think XTDB can be a good fit?
Mm, I right off the bat. I mean, I'm not. I'm fairly well versed with XDDB. Um, I would say that if your use case makes sense to use a graph database and one that is document based, to model your domain problem, then sure, definitely XDB is great, because one of the things that is great about XDB is similar to the rich Hickey idea of like decomplecting systems. So they modeling the same idea from Datomic. Okay, it might not be the same idea of Datomic, but what they do is that you can define what you want to use under the hood for your index store, your document store, your transaction logs. You can use something as simple as like SQLite, or if you want to eventually scale up, maybe you can do a Postgres database for the amount of data that you have, or or MariaDB database. Or if you even want to scale up even further later on, you can change it up to Kafka lah. So in that sense, it gives you that flexibility, and it can uh, cater to diverse teams. Yeah. So I think if you have the use case, I think it's good. Yeah.
Okay, thank you.
I'll chip in with one. I guess. Well, first off, thanks, Zach. That was super interesting. I'd never even heard of Core.logic before this, and to see it in a use case that is totally like relatable was much appreciated. So really, thanks a lot for that. Well, this isn't a question that's so much related to what you presented on as much as what you mentioned, which is like what's with like the adding the O and the E to the end of like con to end member. Like, does anyone have any idea what the purpose of that is, other than just pure differentiation? Because there's definitely different ways to go about doing that. Is it to mimic Latin or something?
I'm pretty sure there is. I would think there's some roots to this with logic programming, like in Prolog. I could be wrong. Yeah. Oh, okay. It's mini Karen, which is what is the underlying system that the solver is using. Like the solver implements like the algorithm, the system of mini Karen. Yeah. So it's probably one of those things, and uh, I as far as the AIOU goes, I guess it derives from that underlying system. But in terms of what's the purpose of it is to do that differentiation. Yeah.
Nice, thanks.
Anyone have any other questions or comments? I'm not sure if Vincent is here, but I know that I think he tried to get me to model other mathematical or sort of other not logic problems, more other like similar puzzles like Sudoku, something like Sudoku, but it's something else. I was yeah, I think of something called like some galaxy puzzle thing. But I think um I'll say definitely like Sudoku is a very like easier to start off with, but and I think that other people give other there are other examples of Core.logic solving other puzzles. I can't recall what I googled, but I think as far as Core.logic went, I think a lot of people did do Core.logic back in like the earlier stages of Clojure. But I think for now it seems like there's not a lot of activity going on there. So perhaps there could be a resurgence of that. Any questions? Comments? Like if pertaining to the talk or anything I mentioned, yeah.
Maybe I'll just chip in with one more.
Right.
And this is a question for you, Zach, but also for everyone else if they run into this situation. But you try to solve the 2x2 grid, but it created a very large number of solutions, and so the calculation took a while. And sometimes you run into this when you're on Emacs and you've like jacked in to some kind of like nREPL. Like what do people tend to do in this situation? What I tend to do is like kill that Java process if I happen to be able to. But I feel like that's not like the cool way to do it. There must be a much better way. So does anyone have a better solution than that?
I don't know, not exactly a solution, but I know I think Nick Tonsky was talking about nREPL and how there's various ways. He wrote an article about it on how to I used to throw out of patience exception. But yeah, so Nick Tonsky had an article talking about nREPL and how there's various ways he believes that it would be better to things he can do to improve the nREPL. And I think one of the ways that he sort of suggested is to have like asynchronous execution so that you don't need to wait upon a form to evaluate before you evaluate the next form. I think there's some problems in terms of how initially it was conceived. I forgot who's that Clojure member that has since like went to do Haskell, I believe. But yeah, so I think there's some discussion here and there. But I can link you the article. Yeah. But otherwise, like personally, I'll just close the like cider or close. I think there's sometimes I needed to use like assessment quit instead. Yeah. I don't know if anyone has any thoughts. Daniel mentions that you can reduce like the print size. Anyway, if no one has any more questions, I think what I want to do is that we can wrap up the Q&A. And what we can also do is, since we have a lot of people still here, can I invite you all to turn on your camera so I can take like a group photo in a sense. And yeah, unless anyone has any questions, you all can quickly shout out. Yeah.
Okay, let me ask a question. So, like, is there any real world use case or application for logic programming?
So I was Googling this, and I think I sort of hinted at it with solvers. So I think generic solvers, like, I'm not sure if Core.logic is considered a generic solver per se, has too much use case. I think the use case that people did have was to sort of do like rules engines of sorts, because maybe you have a lot of business business requirements, and then like you didn't want to have a program that's all go through everything that you wanted. Yeah, you didn't want to write a program yourself. Like you can just use a solver to do that. But beyond that, like for specific solvers that are specific, like ones that solve like linear programming, I think there's definitely a lot of use case in terms of like operation research. Underlying it is also, I found an article on it actually. Let me find it. But anyone else can chip in actually. Yep. So there's this Stack Overflow logic programming article, but they talked about how there's constrained logic programming is very well used. So like for example, if you divide the constrained logic programming problem into ones where you're just dealing with integers, ones that you're just dealing with booleans, and ones that you're just dealing with rational numbers. For the ones where you're dealing with integers, you will be solving things like your scheduling problem, resource allocation problems, planning, combinatorial optimization. Meanwhile, like your Boolean constraints will be your SAT set solving problem or on whatnot. Yeah. Rational numbers will be like your linear programming, mixed linear programming. I think you sort of see the applications really more towards like the math sphere of things, where you model real life problems mathematically and try to like optimize to like achieve like the greatest profit or whatnot. Yeah.
Basically, it's a solver, right? So there could even be potential applications in, say, like AI art or something like that, where if specific squares in an image are like a particular color or shade, then it should fill in other squares the same way or something like that. I mean, could it be applied that way?
I'm personally not informed enough to answer that, but I'm sure someone could link them together. Yeah. Okay. But thanks for adding on, Jeanette.